Okay, we're going to talk about the phases of the action potential. So in a regular cell, during these action potentials, and the action potential is just explaining how electrolytes get exchanged across the membrane to cause something to happen in the heart. So at the beginning of our electrical potential, we're our resting phase. So this is our resting phase. That's number 4. And here I've drawn a picture of a cell. And on the inside of that cell is the potassium, and on the outside is sodium and calcium. So right here, our potassium is here, sodium, calcium out here. So the inside is more negative than the sodium, calcium on the outside, because there's so much more of these positive people on the outside than there is on the inside. So naturally that would mean that the potassium area would be more negative than the outside area with the sodium and calcium. Okay, so this is our natural state. Okay, so for natural state, okay, so here, all right, so here on our action potential, this is called depolarization, and what that means is there is a movement of sodium ion cells into this cell right here. So all these sodiums just push, they run into the cell. So that's why it spikes up so fast. So the sodium just runs into the cell, just bombard it, whatever. And so it spikes up, and those sodium channels are wide open, running inside the cell. So here, we call this early repolarization. And this is where we have the closure of those fast sodium channels. So here, boom, boom, the sodium runs in. Then here they close. And then 2 is the plateau. And this is where calcium begins to move into the cell. And the calcium moves in slowly. Okay, we have our calcium moving in slowly. And all the while, we see all this sodium coming in, all this calcium coming in. And that is making the inside of this cell more and more positive. Okay, so calcium coming in, but it's coming in slowly. Okay, this is 2, and this is our plateau phase. 3, now the cell is like, all right, I've had enough. It's time to go back to where I came from, and we begin repolarization. And here's where the potassium moves into the cell. Okay, so when the sodium was moving in and calcium was moving in and stuff, the potassium was going out. So now it wants to get back to its natural state. So the potassium is coming back. And while the potassium is coming back, the sodium and calcium are going back outside. So 3, we call this repolarization. So our potassium moves back into the cell. And then now we're back at 4. This is where the electrochemical gradient has returned to its normal potential. And it's almost impermeable to sodium. Okay, and so between 3 and 4, this is what we call our refractory period. And that's where if something in the cell had a stimulus, something could occur here. Okay, in this section right here of the action potential. So briefly, I'll go over this again. 4, we're resting. Phase 0, depolarization. All the sodium is coming in. 1, sodium channels close up. 2, calcium comes in slowly. 3, the cell wants to get back to its natural state. So potassium comes in and scoots all that sodium and calcium back out. And then 4, we're resting again. Okay.